Welcome back to math. We're up to section 7 now with ratios and proportions. We'll talk about direct proportion setup, solving with cross multiplication, and an indirect proportion setup. A proportion describes two things that have a fixed relationship. There are two kinds, direct and indirect. We'll talk about direct first. In a direct proportion, if one of the items increases, the other also increases. Think about the example we'll use in a moment of children per teacher. If there are 8 children per 1 teacher, the more children we have, the more teachers we also need. We write direct proportions in a ratio or a fraction with item 1 over item 2. And that equals some constant. The ratio doesn't really tell us how many children or teachers there are in the group or even how many total people there are, but if we know one or more of these facts, we can use the proportion to find the rest of the detail. The other kind of proportion is an indirect proportion, where if one thing increases, the other decreases. A lot of the examples you'll see of this kind of proportion is workers to get a job done, and it's really the many hands make light work kind of an equation. It says that there's a product, multiplication now, where item 1 times item 2 is some sort of constant, and it usually refers to the number of workers, that's item 1, and the hours each one needs to work to complete a particular job, the constant. So we'll talk about setting up direct proportions. Again, a direct proportion is an equation where both sides have equal ratios. The first step is to determine what two things have a relationship. In our example, it's going to be the number of children and teachers. Other examples could be things like miles per hour, dollars per gallon, wages per hour, calories per serving, or even students per classroom. So the next step is to write that relationship in a fraction format. So I've decided that children and teachers have the relationship. It doesn't matter which one goes in the numerator and which one goes in the denominator, but the important thing is that you keep the format the same. So I've started with children in the numerator and teachers in the denominator. I need to keep it the same way. So we're going to apply the other things we know, and that is that there are 8 children for 1 teacher. If a question asks something else to apply this ratio to another situation, it might ask something like, how many teachers do you need for 32 children? All right, well, how many teachers are on the bottom, do I need for 32 children? So now I've got children, all the information of children is across the top, and everything for the teachers is across the bottom, and I've got this equation. Next we'll show you how to solve that with cross multiplication. To solve this type of equation, we use a process called cross multiplication. We'll multiply together the numerators by the denominators across from it, and that's what makes this sort of a cross sign or cross multiplication. So we're going to multiply this A times this D, and we would get A times D. That would be over here, A times D. And we're going to multiply this numerator by this denominator, C times B. And we've written it in alphabetical order here, B, C. Here's the problem we've been talking about. And if there's a ratio of children to teachers that's 8 to 1, notice that a ratio can be written like this with a colon. We read that 8 to 1. How many teachers are needed for 32 children? We've still got children in the numerator, teachers in the denominator. We know that there's 8 children per 1 teacher, and now we need to know how many teachers for 32 children. So 32 is the children, x's are unknown. We're going to cross multiply. We'll do 8 times x, and we get 8x. And then we'll do this cross. 32 times 1 is 32. Now if you remember from solving equations, x is being multiplied by 8, so we're going to do the opposite, which is division. So So we'll divide both sides by 8. That leaves us with x on this side, and 32 divided by 8 is 4. So the answer to the problem is, if we have 32 children, we need 4 teachers. Here's another problem with a direct proportion. If a car gets 30 miles per gallon, how many miles can it go with 12 gallons? So the first step, what is having the relationship here? Well, it's miles and gallons, right? So we'll write this, miles and gallons. So what do we already know? Well, we know that 30 miles per 1 gallon is our relationship. And we want to know how many miles, so I'm keeping miles in the top, and I'll call that x, how many miles, with 12 gallons. Again, 12 is in the bottom because it refers to the gallons. Now we cross multiply. X times 1 is x, and 30 times 12 is 360. So if we have 12 gallons with this car, we can go 360 miles. Why does cross multiplication work? It's really just a little shortcut, comparing fractions by finding a common denominator. I'm sure if you're interested, you could apply what you know about common denominators to prove that to yourself. And don't confuse cross multiplication with multiplying fractions. There's an equal sign here, not multiplying the fractions at all, but we have an equal sign, an equation, and so that is how we're solving this, is to use cross multiplication. Now let's talk about an indirect proportion setup. Remember that in an indirect portion, as one thing increases, the other decreases. So here's our example of how many people it takes to do a job. And this information says that 4 people need 6 hours each to do a job. So the constant is the job, and it's people times hours. So we have 4 people times 6 hours, and that equals 24 hours total to do the job. So now if there are 8 people who are going to share the job, now we have 8 people times how many hours? We don't know. Let's call that y. But it's still going to equal 24. It will still take a total of 24 people hours to do that job. So if we divide both sides by 8, we will get y equals 3. So that makes sense because it's twice as many people. It takes half the amount of time. 8 people can do the job in 3 hours.